Hi everyone, I'm Mikhail. Welcome to the Darkwire Labs YouTube channel, where we break down network technologies and bring them to life with real code. Today we are building a high-performance traffic generator to demonstrate how to measure raw bandwidth between network endpoints, and more importantly, how to simulate and analyze various denial of service attack vectors. Initially, I set out to build a simple tool for application load testing and throughput measurement. However, I decided to extend the project into a security simulation. We'll examine two distinct scenarios: a volumetric UDP flood aimed at overwhelming application logic, and a TCP SYN Storm designed for protocol level exhaustion. For our throughput test, I want to build a tool similar to iPerf. I specifically chose UDP over TCP as a transport protocol for several reasons. TCP requires a three-way handshake before a single byte of data is sent. UDP allows us to transmit at full line rate immediately. TCP is polite. If it detects packet loss, it shrinks its congestion window, slowing down the transmission. UDP allows us to ignore these signals to find the true physical capacity of the wire. UDP header is only 8 bytes compared to TCP's 20 bytes. For the implementation, I asked AI to generate Go language code for me and prepare it for a Docker container deployment. The generator opens a single UDP socket and saturates the monitor with 1400 bytes packets. I chose this size to avoid Ethernet fragmentation while remaining compatible with the smaller MTUs often found in VPN tunnels. The monitor acts as a mirror, immediately streaming a burst of data back to the generator, and by doing this, we measure the full duplex capacity of the link, looking for the maximum Mbps achievable before the onset of packet loss. Let's take a look at the files that we've got. So here are the files that the AI generated for me. So this is the generator code, the monitor code, Docker files, and Docker Composer for the automatic deployment. But to make our test real, I decided to test the bandwidth not between two Docker containers, but between one container and one server on internet. So it will measure my real bandwidth of my WAN link at home. Let me modify the Docker Compose file for that. So here I put public IP address of the virtual machine where I'll be running the monitor. I could remove this code from here because I don't need the monitor container to be deployed here. However, I was talking about this code for the victim and for this victim service, but it's okay. I'll keep it because we'll need it in the next tests. So let me deploy this. Now I'm going, this is my virtual machine in cloud. I'm going to run monitor here to the side. So let's see. Okay. I'll stop it because my full internet pipe now is used. So I don't want it to continue. So as we can see, it measured bandwidth around like 20 to 23 Mbps per second. My actual WAN bandwidth is now around 25 Mbps, so it's pretty accurate. All right, good. But now let's move on to the next test and send traffic between two containers so we can really achieve high throughput. I'm modifying this Docker Compose file once again to put IP address of the Docker container, which will be acting as the monitor. And this time, instead of the just simple throughput testing, we will also run a scenario with UDP flooding. I'll change mode to 2. And let me show you the generator code. So scenario 1 was just for bidirectional throughput measurement. It was just sending packets and adding data in the packets, making large packets and sending them back and forth. But for the UDP flood test, we are going to use smaller packets because our goal is to attack and to overwhelm the CPU on their victim server. And by the way, that's how the monitor program looks like. We added workers here so we can at least queue some packets, because otherwise our monitor application was crashing due to excessive load if the traffic rate was high. Let me build this environment once again. Okay. Now we have two containers. Let me also show it to you. So we have attacker and the victim. Yeah, we can see CPU load is pretty high. I'm not sure if you can also see, yeah, we can see this network input output from here. It's also pretty high, but it's also measured from here. But the main parameter here is actual the packet per second, because the packet per second rate is pretty high here. So now we are really overwhelming the victim machine with UDP. I want to do something. I want to run TCP dump on the attacker. But I need to limit the number of packets. I'll limit it to 10 packets only. Okay, I think I am missing the package. That's Alpine Linux. I need to install this package. Okay, yeah. Let's just take a look what's going on. So my attacker is sending UDP datagram to the victim on port 5555 from the random source port. And yeah, the attacker, that's a small UDP datagram. The attacker is responding with big packet that was needed for our actually bandwidth test. We could change this code. But yeah, I mean, all this traffic is just a number of incoming connections to the victim and the victim responses. Okay, good. And our last test for today, what I want to show you is the TCP Storm. So what we want to do, we want to send excessive number of TCP SYNs to open as many new TCP connections as possible. And we are not going to properly handle TCP three-way handshakes. We are sending SYNs only. Normally you would see this kind of attack as a distributed DDoS attack. So this will be coming from various hosts across the whole internet, coming to specific victim in attempt to just exhaust its resources and bring it down. Alright, that's going to be mode 3 for TCP. Yeah, that's TCP flat. Okay, for this test we will need to... The traffic rate is not that high, but traffic rate doesn't really matter here. And one interesting fact here, you see that the CPU load on that attacker is significantly higher than the CPU load on the victim. And actually, I believe that's because of some protection mechanism of the operating system that protects our application. We could play more with it to create more realistic tests when the CPU will be affected. But that's not purpose of my demonstration. Here, what we can do, I'm going to install network tools and watch statistics for TCP SYNs. Yeah, you see that how this number is growing. But although this number is growing so fast, still my server is not crashing, so that's how the kernel is protecting it. Let's run TCP dump just to see how traffic looks like. Alright, so it's SYN, SYNAC, SYN, SYNAC. In fact, this attack will have much more success if we had a firewall in between, because this will exhaust all connections, all connection pool, all connection limit on the firewall, because although for server it's taking resources to open new connection or to respond to connection, but it's also consuming resources of the network firewall to inspect it, because the firewall creates new connection, the connection table, and it writes some logs. So from my experience, if there is a massive DDoS attack, the firewall will suffer first. Although it all depends how powerful the firewall is. Alright, I hope you enjoyed this video. See you next time. Thank you for watching.